Lesson 9.5, page number 649, scientific notation. And there's a scientific notation definition in brownish tan colored there. A number is in scientific notation when it is written as the product of a number between 1 and 10 and an integer power of 10. Alright, so let's do that in English. What they're saying is we can take any number. Let's take 186,000. Okay, that's the speed of light per second. That's how many miles light travels per second. So, in science, a lot of times they'll want to take this number and make it appear a little bit different because sometimes it's easier to work with, and calculators like it a lot better. A calculator, it's real hard to put a number with 26 zeros after it in your calculator, so there's a method of doing that you can store that information in your calculator and have it solve the problem even though you can't write the number that big in there. So what that definition says: a number is in scientific notation when it is written as the product of a number between 1 and 10. Alright, so what we're going to do is we're going to take this number and change it from a 6-digit number to, we're going to write it as basically a 1-unit number. Okay? So what we're going to do is we're going to look at the first number and put a decimal point just to the right of that first number. And then we're going to write the 8 and the 6. These zeros we're going to ignore. So, this number here will never be 2 digits. It will never be 10 or greater. It will always be less than 10. It may be 9. I guess the biggest number this number can be is a 9. So it's going to be between 1 and 9 always. Never is there any other option available. Always be between 1 and 9. Or a number from 1 to 9. It will never be 10. Then a decimal, and then the rest of it. Okay? So we're writing this number, but we're writing it in a different form. Okay, so always works. 186 we're going to write as 1.86. Then we're going to put a times sign, and we're going to put a 10. And then what we're going to do is the decimal on this number was originally right here, wasn't it? 186,000 decimal. Where we moved it 1, 2, 3, 4, 5 places. Well, I need to tell you where that decimal is really supposed to go, so you know when you move it back, you'll get this number back. So we moved it 1, 2, 3, 4, 5 places. So I'm going to put a 5 up there to represent how many decimal places I have to go back to make it into its original number. If I have a number such as 8.64 times 10 to the 4th, that number is in scientific notation. That's what scientific notation looks like. Whenever you see a number, the number to the left of the decimal is a number less than 10. There's a times 10 here with an exponent. It is in scientific notation. When it's written like this, it's called standard form. So standard form is how you're used to seeing it. Scientific notation looks like this with a times 10 to some power. So they're going to be asking you to go back and forth. Example 2, bottom of page 649. Write 8.64 times 10 to the 4th in standard form. So what we're going to do is we're going to take our 8 and we're going to just stick a bunch of zeros on here because I'm not sure how far we're going to go yet. But this says that in order to go back to what it's supposed to look like, I'm going to have to move this decimal this way 4 places. So 1, 2, 3, 4. So my new decimal is going to go there. So I can erase these 2 zeros because I didn't use them. Okay. So now my number is 86,400. Okay. That's about all there is to this lesson, going back and forth. So we're going to do a couple examples here on page 651, problem set 9.5. And we're going to look at ones like, well, let's look at number 6. 29,000. Then I'm going to teach you something new here that it looks like I might have skipped there at the bottom of page 650, but we'll just keep going. 29,000, and it's asking us to take it from standard form and writing it in scientific notation. So I know all I'm going to do is write that number, dot, the rest of it until we get to zeros, times 10, and then I'm going to count how far I had to go to get here, because I was here. 1, 2, 3, 4, and I'm good. If I'm given 5.71 times 10 to the 7th power in order to go to standard form, again, I'm just going to write 571. I'm going to start adding a whole bunch of zeros here, and my decimal was here. 1, 2, 3, 4, 5, 6, 7, because that said go over 7. So that's my number. 57,100,000. Okay, so bottom of page 651. Well, in fact, let's look at 17 through 24. We've got a little bit of different situation here. Look at 18. 0 point, let's see, how many zeros are there? 5, 2, 3, 4, 5, 3, 5. Okay, that's standard form because you don't see 8 times 10 here. So that's standard. We're going to write it in scientific notation. That means that the number to the left of the decimal has to be a number between 1 and 10. Where is that? Right there. If we write it as 3.5, the number to the left will be a number between 1 and 10, and I don't care what the numbers to the right are. Okay, so I went. Alright, in order to get this, once I write this, once I get this over here, I had to go 1, 2, 3, 4, 5, 6 numbers. But what did I do? I went the other way. So when I was going to the left, that number was a positive 6. 1, 2, 3, 4, 5, 6. But when I go this way, it's a negative number. So, anytime you are dealing with numbers where the left-hand side of the decimal doesn't exist or is a 0, this is going to end up being a negative. Okay? If I had 367,000 and my decimal's there, I've got a bunch of numbers over here to the left, okay, that are larger than 0. That means my number is going to be positive when I convert to scientific notation. But when my number to the left of decimal is 0, my exponent is going to be negative. And all that is doing is telling you what direction you're moving your decimal. So if I've got 0.1276, alright, I don't have anything here, so I can just automatically write 10 with a negative number. And I moved it over how many? 1. So because I only moved it over 1, I put that there. So that's a good clue, just remembering the number to the left, if it's 0, your exponent is going to end up being 0 there. And then they will have you go the other way. They're going to give you something like this and want you to write it in standard form. Well, what you're going to do is you're going to write it again with your 0 over here on the left of the decimal. Right now you have a 6 to the left of it. We're going to move that decimal so that 0 is to the left of it. Notice it's a 2, so I moved it from here 1, 2 to the left. When I moved it 2 to the left, that put a 0 here because there's no number in front of there, so I know I wrote it in standard form. So, good thing to remember, if your exponents are negative, when you write a scientific notation into standard, you're going to have to make it so there isn't a number to the left of that decimal. You're going to move it over enough, that way. If you were given it to this way, it has a 0 written there, so you know then that you're going to have an x times 10 to the negative here, and you're going to count how far you have to go to get it into scientific notation. We moved it 1, 2, so we have a 2 there. Okay, so that's problem set 9.5.